Welcome to episode 8. This week we will talk about radiometric dating. Radiometric dating is another big and controversial topic. We will do a brief overview of how it works, discuss the assumptions that the secular scientists make, and then discuss why they are wrong. So first, what even is radiometric dating? Radiometric dating is a method that scientists use to assign dates to rocks, fossils, and archaeological objects. The date assigned to any given object via radiometric dating is often treated as authoritative. In the media and textbooks, these dates are stated absolutely, with the expectation of there being no questions asked. In the biblical creation timeline, the Earth is 6,000 years old. We get this number from the genealogies in the Bible. If one does the correct math, given the genealogical data in the Bible from Adam to Jesus, one finds that the time from Adam to Jesus was 4,000 years. And then it's been 2,000 years since Jesus, so that makes the Earth 6,000 years old, according to the Bible. However, radiometric dating methods assign ages of millions and billions of years to the objects that are tested. How can this be? Does the science contradict and therefore disprove the Bible? Are the people who don't believe in the Bible correct? Or is there more to the story? Let's find out. Radiometric dating measures the decay of one element to another. Elements, if unstable, will decay over time in order for the atoms of that element to be stable. Different elements decay at different rates. Based on the rate of decay and the amount of each element in the object, scientists make assumptions in order to assign an age to an object. Let's go a little deeper in order to understand this better. Elements are made up of atoms, and atoms are made up of protons, neutrons, and electrons. The protons and neutrons are in the nucleus and the center, and the electrons orbit that center. Each element has a number of protons, neutrons, and electrons in order for the atoms of that element to be stable. If the components of an atom do not meet these numbers, it is unstable or radioactive. The atom must then add or lose components in order to be stable. Some atoms lose neutrons and protons. However, this results in a different chemical element, because the protons for an element are always the same no matter what the number of other components are. So therefore, if the number of protons changes in an atom, it becomes a different element. In these instances, the original element is called the parent element, and the resultant element is called the daughter element. This is what is referred to as decay. Radiometric dating methods measure this kind of decay. However, only the decay of certain elements can be measured. Unstable atoms, variations from the stable atom, are called isotopes. Some examples for isotopes would be carbon-12, carbon-13, and carbon-14. There is the same number of protons in all of these isotopes, but each one has a different number of neutrons. Some examples of radioactive isotopes are uranium-lead, samarium-neodymium, and rubidium-strontium. The first element is the parent element and the second element is the daughter element. Like I said before, radiometric dating methods measure the amount of the parent element, the amount of the daughter element, and the rate of decay. Then I said there were assumptions needed in order to achieve the assigned date. But wait, aren't scientists just supposed to know things absolutely, instead of making assumptions? They sure don't act like they make assumptions, but they actually do. So let's take a look at them. There are three main assumptions we will talk about. I will go through them one at a time. The first assumption is about the conditions at time zero. Time zero is the point in time at which the rock was formed or the organism died. There are multiple dating methods to date rocks, and carbon-14 dating is used for dating animals and plants or other organic matter like oil and coal. The processes are similar enough to consider them the same for the sake of this discussion. When a rock or fossil is dated, the rate of decay is calculated backwards to time zero. However, since we are not able to test the rock or fossil at time zero, we do not know the initial quantities of elements in that object. For an example, I will use numbers with illustrative purposes only. Say a rock has 50 parent elements when created thousands of years ago, inherited from the lava of which it was formed. Then, in the present day, when scientists go to calculate the age of this rock, they determine that they will calculate back to 10 parent elements in order to find a date for this rock. The problem with calculating back to 10 parent elements is that the rock actually started with 50 parent elements. So the age that the scientists will conclude with will be older than what the rock actually is. The second problem is the scientists chose the wrong starting point because they had no idea what it was in the first place, because they weren't around thousands of years ago. So, for any given rock, if time 0 is assigned to a point that has less parent element than what it started with, the age will be older than the rock actually is. That means that the date assigned is not absolute and could be potentially inaccurate because the calculations were based on an unsubstantiated guess. There is even some observational data that highlights the problem with this assumption. There are instances where rocks, whose formation was observed in recent volcanic eruptions in the past few decades, were dated to be hundreds of thousands and millions of years old. One example is a rock from the hardened lava flows from the eruption of Mount St. Helens. Its formation was in 1986, and when analyzed in 1996, the rock was aged 350,000 years old. Why did this happen? There was more argon-40, the parent element, in the rock than initially expected. So the test got the age of the rock wrong, far older than what it actually was. If radiometric dating methods failed to age a rock whose formation we did see, how much more would it fail to date rocks whose formation we didn't see? Another example of a rock dating older than its actual age was a rock from the lava flows of Mount Norohoi in New Zealand. The rock, known to be less than 50 years old, was dated to be 3.5 million years old. Another phenomenon is the basalt in the Grand Canyon. Basalt is lava that hardened at the Earth's surface. In the Grand Canyon, we find basalt at the bottom layers of the canyon, and also basalt after the canyon formed. The natural assumption is lower rock layers will date older than higher rock layers, because rock layers at the bottom were put there first, and rock layers above them were put on top of them later. Creationist geologist Andrew Snelling dated samples from both of these layers of basalt. He found that when using the rubidium-strontium dating method, he found that the rocks formed after the creation of the canyon were the same age that the rocks formed at the bottom of the canyon. This radiometric dating result contradicts reality because there is no way that rock from a volcanic eruption after the formation of the canyon would be the same age as rock from a volcanic eruption at the very bottom of the canyon. Something is wrong somewhere. Andrew Snelling concluded that there must have been daughter elements at the formation of the latter rock, giving these rocks the appearance of decay. So even though the rocks appeared like they decayed, they actually didn't. But this initial existence of daughter element caused the rock to be dated way older than it actually was. The next assumption is with contamination. It is known that rocks can be contaminated. Contamination is the gain or loss of parent or daughter elements. Contamination in rocks can happen by the flow of groundwater, rainfall, or the flow of lava. The impact of contamination on the radiometric dating methods is intuitive. For example, say a rock had 50 parent elements, but then groundwater deleted 20 of them, therefore leaving 30 parent elements. When the scientists go to date this rock, the age will be inaccurate because the observed decay does not reflect the entire lifespan of the rock. When it comes to carbon in animals, the carbon of an organism could be impacted by things like bacteria or fungus, which could add or subtract to the carbon quantity, and therefore throw off the calculation for the age of the object. Obviously, there is no way to go back thousands of years in order to determine how rock samples were contaminated. So, after the first two assumptions, two of the three variables necessary for radiometric dating can be held in question. We have seen how the amount of parent and daughter element observed right now is not reflective of the actual age of the rock. That leads us to the third variable, rate of decay. The secular scientists assume that the rate of decay for elements has always been the same throughout Earth's history. However, the problem with this is that we have not actually been able to measure the rate of decay throughout all of the history of the planet. This is the assumption of uniformitarianism. Uniformitarianism assumes that All things continue as they were from the beginning of creation. One of the more common conclusions of uniformitarianism is that rock layers are laid down one at a time at the same rate. And since there are lots of rock layers, and they were all laid down at the same rate, this must mean the Earth is really old. Similarly, the rates of decay that we see now have always been the same. However, since there are no measurements from the past, there is no way to verify if this assumption is true. Perhaps the decay rates were different, and we don't know about it. However, there is some evidence that suggests the opposite of uniformitarianism, that perhaps rates of change in the past are different than what we see today. I will go through some examples of this evidence. First, let's consider some crystals and some granite from New Mexico. We will consider another study done by Andrew Snelling. He did a study measuring the radioactive decay of uranium in granite-based crystals. He found that the crystal aged to be 1.5 billion years old. Uranium decay produces helium. He also measured that 6,000 years worth of helium leaked out of the crystal. There is a contradiction here. The rock cannot be both 6,000 years old and 1.5 billion years old. Unless the measurements were inaccurate, this would mean that 1.5 billion years of uranium, according to the rate that we observe today, would have had to decay within 6,000 years. The decay of uranium would have to be 255,000 times faster than what it is today, in order to reconcile both of these measurements. Next, multiple kinds of elements can decay within the same rock sample. One would expect that all of the dating methods would get the same age, because one rock can't have multiple ages. However, this is not the case. There are numerous examples of different dating methods getting different ages for the same rock. Going back to the rocks of the lava of Mount Naurahoe, in addition to be dating 3.5 million years old, because of contamination, the rubidium-strontium method dated rocks at 133 million years old, the samarium-neodymium method dated rocks to be 197 million years old, and the uranium-lead method dated the rocks to be 3.9 billion years old. Next, revisiting the basalt from the volcanic eruptions after the formation of the canyon, the rubidium-strontium method aged the rocks to be 1.143 billion years old, the samarium-neodymium method aged the rocks to be 916 million years old, and the uranium-lead method aged the rocks to be 2.6 billion years old. Conditions at time zero, contamination, and variation of rate of decay could all be factors in the differences of these ages. Andrew Snelling did another study trying to examine the potential of different decay rates over time. In this study, he used 4 different dating methods on 4 different types of rock. The 4 methods used were potassium-argon, rubidium-strontium, uranium-lead, and samarium-neodymium. Not only did each dating method get a different age for each rock, for the different rocks, potassium-argon consistently had the youngest ages, rubidium-strontium had the second youngest ages, uranium-lead had the second oldest ages, and samarium-neodymium consistently had the oldest ages. Snelling concludes that, even though the decay for each of these elements started at the formation of the rock, each of the radioactive elements must have decayed at different and faster rates in the past. You may be wondering, well, how then do they know which method to use? We'll get there soon. We will go back to carbon for the next example. Supposedly, in fossils older than 100,000 years old, there should be no detectable amounts of carbon, because carbon decays over time. The Marlstone rock bed in southern England, the rock layers were dated 189 million years old. However, there are wood fossils in these rock layers. So, since the wood fossil is the same age as the rock, because it is inside of it, one would expect there to be no more detectable carbon in this fossil. However, enough carbon was detected in this wood sample to give it an age of 20,000 years old. How can a fossil be 20,000 years old in a rock that's 189 million years old? Something obviously isn't right here. Perhaps the assumptions are wrong somewhere. Next, I stated earlier that uniformitarianism assumes that rock layers are distributed at a uniform rate over time. However, it is easier to see this in a picture, but there are places where we see many large rock layers bent at 90-degree angles. This could mean that all of these rock layers were laid at once, and then shifted in the same pattern, or many years after these rock layers were laid flat, over the period of many years, some pressure caused multiple feet of hardened rock layer to be bent at a 90-degree angle. Well, this is actually impossible. So perhaps these rock layers weren't laid one at a time at a constant rate. Andrew Snelling has a 2-part video series going deeper into the details of this phenomenon on YouTube. You can watch them if you are interested. Another interesting thing to consider is that there actually have been studies that have dated rocks to be negative years old. I have a document listing these instances in the sources. Also, there are rocks that date older than the secular scientists' proposed age of the Earth. Those are in the previously mentioned document as well. The author of this document includes quotes from the actual studies that found these rocks to be negative ages. And the secular scientists are like, that's awkward. Next question. I guess those studies don't make the headlines or the textbooks. So you still may be wondering, since different dating methods get different ages of the same rock, and they sometimes get negative ages and ages older than the age of the Earth, how is it known which measured age to use? Here's a quote from a book about geological evolution by E. Bates McKee that summarizes what happens. Quote, "If the laboratory results contradict the field evidence, the geologist assumes that there is something wrong with the machine date. To put it another way, quote, good dates are those that agree with the field data, fossils in the strata." End quote. So this means that if there is data that contradicts the preconceived conclusion, it is discarded. For example, if there are 3 rock layers, the bottom one dates 30 million years old, and the top one dates 10 million years old, and the middle one dates both 20 million years old and 50 million years old, the 50 million years old result will be conveniently swept aside. So instead of wondering if their entire data set is in question, they just remove the data that's inconvenient for their narrative. If something contradicts the preconceived narrative, it is assumed wrong, and then removed. So if different dating methods have different ages for the same rock, the date that fits the best with the narrative is kept, and the other ones are irrelevant. Here's a quote by Jerry Trout explaining how good the secular dating methods are. Quote, "From 1924 to 1988, there was a visitor's sign above the entrance to Carlsbad Caverns that said Carlsbad was at least 260 million years old. In 1988, the sign was changed to read 7 to 10 million years old. Then, for a little while, the sign read that it was 2 million years old. Now the sign is gone." End quote. I wonder what things the secular scientists say we know for sure right now will be discarded in the future. I've mentioned some of the dating methods already, but I will read a list of them so we can get a taste of what's out there. Types of dating methods that exist are uranium-lead, samarium-neodymium, potassium-argon, rubidium-strontium, uranium-thorium, radiocarbon, fission track, chlorine-36, and luminescence. Again, which one do the scientists choose? The most convenient one, of course. To summarize, even though radiometric dating is treated as authoritative, it is actually unreliable. It is unreliable because there are multiple unknown assumptions that are necessary for its conclusions. There is no way to tell how much parent or daughter elements there are, and the rate of decay may or may not be constant. With radiometric dating, we have another example of the difference of interpretation of evidence. All scientists look at the same rock. However, the secular scientists, with their unprovable assumptions, interpret the rock to be millions of years old. The creation scientists look at the rock and expect it to fit into the biblical timeline. Furthermore, life is not all about radiometric dating. There are other phenomena that could be used to set the max age of the Earth. They may say rocks date to be billions of years old, but like I said last time, if there's something in the universe that proves that it can't be billions of years old, then that ends all old Earth theories. Here are a few Earth age limiters. One is the recession of the moon. We can observe that the moon is slowly moving away from Earth. The rate at which the moon is moving away from Earth, if it is calculated backwards, the moon would have been touching the Earth 1.5 billion years ago. However, the secular scientists say the moon is 4 billion years old. This is an obvious dilemma for their theory, but maybe there's a proposed model out there somewhere. The next 2 things are topics we've already discussed. The Earth's magnetic field and comets. Both the magnetic field and comets have a limited expected lifespan, the magnetic field being 20,000 years, and comets being a few million years. both significantly shorter than the secular scientist model. Another one is soft tissue in dinosaur bones. In 2005, a scientist discovered a dinosaur bone that still had flexible blood vessels. Could flexible blood vessels have survived tens of millions of years? Most likely not. They're still trying to figure that one out. The last example for now is human population growth. Human population growth has skyrocketed exponentially in the past few hundred years. This pattern fits perfectly with a biblical timeline that says the modern human population would have started 4,500 years ago after the flood. However, the secular scientists say that humans have been around for hundreds of thousands of years. That would mean that essentially there was zero population growth for tens of thousands of years, and then all of a sudden in the past 200 years, it skyrocketed. Why would there not be more humans if we've been on the planet for over 100,000 years? Well, I think they're still trying to figure that one out too. And that brings us to an end of another episode, wrapping up another key topic in the debate. Join me next time and we will discover what a day is.